Okay, well, welcome everybody. Thanks for the opportunity to talk a little bit about Global Composting Solutions. And I do apologise in advance if I'm going over some, pretty basic information. And, please feel free to signal out if you want me to repeat anything, but I'll, try and sort of, touch base on what's happening. So Global Composting Solutions, okay, here we are. We're a privately owned New Zealand company. Now, the company was based on a technology called HotRot. I'm not sure those that's been around the composting industry for many years would remember that, probably from almost 20 years ago now. In fact, the patents have just lapsed in the last few years. Now, it was actually a technology that was developed out of the RONS and the Wool Corporation here in New Zealand, in Christchurch, for pulling lanolin out of wool, and they realized that all of a sudden there was a it was a technology that could be advanced to sort of processing anything that was putrescible, and so they adapted it and they tried it out with putrescible waste such as foods and sludges, and had some real good success. The system heated up and everything worked perfectly. So this was 20 years ago, before composting became such a key topic. So, we now have systems over, in 15 countries. We've probably got 50 or 60 units now across the globe in various sites and various sizes and various applications. So why, global composting? We're, as I said, New Zealand-based company. We deal with difficult organic waste streams. So, a lot of times, some of the problems we're dealing with, some of the food organics and meats and things like that is, problems that you have with, with odor, with leachate, with vermin attraction. And what, the HotRot represents is an opportunity to deal with that in a very environmentally friendly manner. It's enclosed, and basically it stops that, real problem that we have. We just don't, provide a system, we provide a solution. So what we do is we work with our clients to analyze the type of waste that they're dealing with. We look at their sites and, the population, and we then design a system that will suit their application based on, budgets, based on space. So it's not just, it's right across the globe. So, what is composting? Well, it sounds like I'm preaching to the converted. Everybody knows that. So I won't bother going into that. So the two main things that we sort of deal with around the globe is, everybody sort of, looked at, the two main, which is, your aerobic or your anaerobic composting. So tonight, all I'm doing is focusing on the aerobic composting. We all know the benefits of each. So again, there's probably no reason to go into that in too much detail. So why compost? Well, we all know that, the improvements in soil structure and porosity creates a better plant root environment, improves water and filtration and porosity, reduces soil erosion, adds nutrients to soils, introduces the viable organisms back into the soils, promotes carbon into the soils, reduces the waste to landfill, and reduces the release of methane gases. All those things are really, to me, have become a real issue. Certainly in current times, when we start talking about global warming and, soil degradation and, recropping and things like that, we're really destroying. So we really feel like we're in a good space, and we think that, whilst waste can be used for energy and other uses, to me, the number one is basically recreating Earth, making it better, making the soil that, that's going to sort of sustain our, our families and our future, because we really are depleting those, those elements within it. So the most common aerobic composting, again, you'll all be familiar with. We've got open windrow, we've got aerated static pile, and then you've got the traditional in-vessel composting. Now, that could be a system like ours, or it can be these big commercial systems that we talk about, which you see in some of the big municipalities, which are in-vessel tunnels, aerated tunnels. So there's lots of systems out there, and to be fair, each and every one has its features, pros and cons. Open windrow, you look at it, it's a basic system. It's relatively inexpensive. It's known and reliable technology. It's flexible, and it's good for stabilizing homogeneous compost. It's not really good when you start talking about adding a lot of food waste into it, because that's when you get the vermin attraction. You're trying to get the balance in the mix, which can cause some real problems. Aerated static piles with covers, again, I don't want to sort of elaborate too much on that, but it's good for high volumes. It's low power requirement. It's faster than the open windrow composting because it retains the heat. You can control the aeration, and your price point is sort of midway between a straight windrow and then to a full or composting system. It's still rapid. You can, using an aerated static pile, you can look to compost within 2 to 3 months, whereas a full open windrow you could be up to 6 months. But again, horses for courses. When you're talking large volumes, if you've got plenty of land, there's nothing wrong with an aerated static pile with a cover. Then we come to in-vessel composting, and specifically I'm going to just focus on the HotRot system and what we've designed it to do. So one of the pros we have is we have a very small footprint versus volume. You take the picture there now, which is our small 8 and 11, that'll process 2.5 tons a day every day. It's automated, so there's low labor requirement. It's consistent in quality. It's fully enclosed, so there is no odor, no leachate, no vermin attraction. It can be operated indoors or outdoors. Ability to control and monitor, which is really, really important in this environment, is we can check batches, we can check the temperatures of each batch, we can adjust airflow, if the compost isn't getting enough oxygen. So it allows us to take complicated mixes of compost, and we can almost adjust the inputs to create that perfect environment for the organisms to really take off. It is, once it's up and running, it's a low operating cost, and it's rapid composting. So within 10 to 12 days, you're going to have a very, very stable product that comes out, no odor, no leachate, and you're just looking for it to final cool. So it's a very rapid, so hence you don't need a lot of space with open windrows, which can take up to 6 months. Some of the things against it, the initial capital cost obviously puts a lot of people off, and it's really best with high energy food and green. If you're just going to deal with green waste, I'd say don't buy HotRot. If you've got a problem feedstock that you're trying to deal with, which is high in energy, then the HotRot is perfect for that application. And it does, as I said, it does require the balance of carbon and nitrogen. Some of the things that we've been faced with and challenges in some locations is they have a real high percentage of green waste, and they're only just getting onto the collection of food waste, so they don't have that energy to really sort of get the system working. And then other occasions in some countries, they've got plenty of food waste, but like in the Middle East, in Saudi Arabia, we've got 4 units over there. They really struggle getting the carbon source for the process. So having that balance and having that, so this is where, typically we would go into a site, we would do an audit, and we would look at all their waste streams and then try and tailor the best solution, for them. So some of the things to think about when, planning a resource recovery facility, you need to look at the land available. Have you got plenty of land? Because a lot of that will dictate what technology that you do go for. Like I said, some of the aerated static piles with covers, if you've got the land, that's good. It's great if you've got the space to use it. But a lot of the application for the HotRot, they don't have that ability of land, because land does cost. So something more compact is, it's more appropriate. What is the climate? If you're struggling with a lot of rainfall in your area, well, that's not really ideal when you start having open windrows, because you've got the consistent problem with leachate and with water and with cooling the compost, and it's just hard to get it. So the in vessel sort of works very well for that. What consents are there? Are the odor consents, that you need to consider about, product certification, what is it you want to do with the end product, and what resources are available. Do you have a shredder on site? Is there a loader on site? What infrastructure? And these are the sorts of things that we would look at, and to help sort of steer people in the right way to minimize the cost of setting up a really good, effective system. So the HotRot technology, we'll just move right into that. It mimics what happens on the forest floor. It's all we're doing is creating the perfect environment to allow the microbes to grow fast, and to create the energy to, go through that whole composting process. The HotRot system, it's a bespoke design, which I've touched on. Rapid aerobic digestion. It's a continuous flow, and that is really important. There's a lot of systems out there which offer batching, where you load, you might get 10 tons of waste and you load it up, and then you have to shut the doors and you aerate it and you do different things. But the problem is waste is consistent. It happens every day. So for the next 10 days, what do you do with the waste? So you have to have a bigger system to cope for that. So what we do is we look at the amount of waste that's coming in on a regular basis, and we size the system accordingly. So the idea is to get the waste into the system as soon as it hits site, so then you've got no danger of odors and vermin attraction and things like that. And that's the beauty of having it continuous. So every day you're putting 2.5 tons, for example, in our mid-size unit of waste in, and every day after the vessel is full, you're getting compost material out the other end. Features and benefits, as we've said, it's locally designed and supported, fully enclosed, accelerated composting, odor-free guarantee, no leachate, effective aeration based on mechanical agitation, which we'll touch on in a bit, small footprint. It's fully automated. Once the hopper is loaded, you close the lid and you just let the system do itself. Continuous flow, low noise. It's a proven technology. We've had systems, and we have systems out there now which are over 15 years old in applications, and they're still going strong and well proven. And it's very, very low power consumption. For every tonne processed, it only uses 26 kilowatts. So the power is only used to drive the main shaft, drive the exhaust fans and augers. So we don't apply any heat. All the heat which is generated in the vessel is all through the composting process and microbial activity. And the other benefit of our systems, which we'll touch on towards the end of the presentation, is it's expandable. A typical food stocks, which would be food, canteen waste, animal manures, litter, bedding, landscape waste, sewage treatment plants, mortalities, and soil separated organics, green organics. We have applications now where many councils, mine sites, zoos, universities, island resorts, campgrounds, food processing industry, industrial waste, and agricultural activity. So we pretty well, I think, have got something in at least one of those around the globe. So this is a typical flow chart of what happens. I'm not sure how you can see that, but it just shows an example of a system that comes in where you may have curbside commercial collection coming in. You may have commercial collections. Each waste stream comes in. you've got manual sorting and inspection. You then have your green waste coming in, and then basically through a shredder. So part of what we do is look at each area as it relates to the particular application, and we develop the system to basically close the loop on the flow.
Good.
So in general, the process takes 10 to 12 days to break down. Stabilizing, we recommend that it would take 4 weeks. So after the product leaves the vessel, it's going to be hot, and what we're probably around about that 50 degrees Celsius in temperature, and it's still composting. It's very hot. It's very active. The bugs have converted it into a good stable product, but it will still get hot. So what we try and do is we encourage people, if they're going to use it and bag it to sell it, is you want it to cool, but at the same time you don't want it to overheat. So we suggest storing it for 4 weeks in a static pile. You maybe turn it once a week to release any energy that's within it, release the excess moisture, because composting, as you know, if you leave it sit, it can get up to temperatures of 65, 70 degrees. And when you get into the center of the pile, you'll find that it's heated to the point where you've killed all the good bacteria. So you try and maintain the temperature, best you can in that last sort of phase of stabilization. So the HotRot system itself consists of your main vessel. You've got your inputs being your waste and your carbon, a main hopper, and things like bin lifters. Depending if you've only got a small volume, you may not have a wheel loader to load the hopper, so we supply bin lifters. You've got your electronic control, and then you've got your center shaft that runs through the vessel, which is basically key to keeping the whole process oxidized and making the whole system work. So as we said, we've talked about the continuous flow. There's very minimal moving parts. You've only got the one main shaft that runs through the vessel. The main shaft will turn every 60 minutes. It may turn for 2 or 3 minutes forward and then 2 or 3 minutes back. And so it's not like you've got a lot of wear or anything like that, a lot of mechanical moving parts. It's just that one shaft which just ticks away, which uses very little power, and it just sits idle until it's required to do its job in another 60 minutes. The systems that we provide an odor-free guarantee. So the whole system operates under negative pressure. We have air injection injecting into the waste, which happens every 30 or 40 minutes in a cycle. As the shaft is rotating, we inject air. And then we have an exhaust fan which runs across the top of the vessel. And you can just see it there in the picture. There's just a little area at the top. You'll see the exhaust fan sitting, which draws air back through a biofilter. So what that does is that ensures that we're drawing moisture out of the compost, excess moisture. We're capturing odor, put it back through the biofilter, which is all a natural process. And then we control it because we've got negative pressure in the vessel. We're controlling any odors that might be emitted from the food. No leachate. The only leachate that occurs is as we're evaporating off the excess moisture out of the system. It's basically like you used to when you were at Boy Scouts and you'd go and you try and find water. And the base, you put the plastic over and you would evaporate it up and you get the condensate. That's what comes out of the HotRot system, because we're taking that condensed hot air, putting it back through the biofilter, and then you get a collection of clear fluid, which you can see here on the bottom. The nutrients, which is something that hasn't been through our process, is all left back in the soil, which is what we're trying to do. We're trying to leave all the goodness back in the soil. So the main controller, we monitor that. That's a live situation that could be hooked up so you can watch it operating on a remote site, so you can have this thing going 100 kilometers away. You can dial in, you can see the temperature of the material as it's passing through the vessel. And typically what will happen is the material, as it starts to compost, by the second phase of the process within the vessel, there's 6 probes, you'll start getting temperatures up around the 40, 45 degrees. By midpoint, you're probably reaching around 50, 55 degrees, and then starting to cool towards the end. And that takes a 12-day period for the material to pass through. As fresh material is put in, it's pushing the composting material towards the end. The microbes from the composting material attacks the new material coming in, so it speeds up that whole process, and hence why we can manage to, compost within 10 to 12 days. The control panel is, it will record data, so we can record things like weights, temperatures, airflow, moisture, CO2, pH, machine cycle times. If the machine has a blockage, it will send alerts to phones. So it's quite a smart interface to help manage the thing with little labour required. So we have 3 main units. We have our small 1206, which you can see there. The 1206 would be typically something that you would put in maybe a small university or a campsite. That will process between 300 and 500 kilos a day of total waste. That's food and carbon. Our 1811, which is our mid-size unit, will do 2.5 tonnes a day, and that's probably our biggest seller. And then we have our very large vessel, which will do 10 tonnes a day, and that's typically in applications like we've got 3 of those in the city of Buenos Aires, dealing with big sort of industrial and municipality waste. Now, I believe that we will share these with you, so you'll be able to see the detail, and it gives you some of the physical sizes, typical power requirements, the footprints required. So our system, as I said, it uses around about 25 to 27 kilowatt hours for every tonne you process. So we're talking maybe just a few dollars in electricity. That's some information without going too far into it. On our 1206 gives you the physical size. Sorry, on the 1811. So the 1811 is it's just over 11 meters long. It's 12 meters long, and 2.2 meters physically wide. So not a big vessel in the scheme of it. And then we've got our 3580, which are a big concrete construction. They're a massive, they're roughly 18 meters long and 3.5 meters in diameter, the internal chamber. Some of the other things we can make is we provide trommel screens and watering systems. So a lot of applications where they're dealing with specifically food waste. Food tends to be really high in moisture. You can be up to 80%, and which is great, but the thing is you need more carbon then to help the process and balance out the whole moisture content for the composting process. So we can supply dewatering to reduce that, make the systems more efficient. So the composting plant of the future is what we'd like to think we are, even though we're sort of 20 years now in the sort of development stage. A couple of screenshots there of just reference sites. We've got the Melbourne Zoo. That system now has been installed since 2012, so it's over 10 years old now, processing all the animal waste and canteen waste from the zoo. Absolutely love it. They actually supply the end product to a local composting outfit who bag it, and I think they branded it Zoo Poo, and it's highly sought after. Another system there, which was installed in 2010, was for the Sierra Nevada Brewery in the US, dealing with all the hops and spent grain and food waste from their cafeteria. And then they use the end product back on their land for, to regenerate the agriculture. And then recently, our recent installation, we've just put 2 units in the city of Geelong, dealing with local curbside collection waste. That's just a few examples. So when we talk about expandability of our system, this is a simple 1811. And the beauty about it is if a client came to me and said, look, we're looking at introducing a waste collection into our area, we think we can have an uptake of, a couple of tonnes a day, we can develop the system in such a way that we would say, okay, well, you don't need to go and spend, X amount on the system right away. We can, the infrastructure in place, and we design it so it's expandable. So this system here, for example, which is what happened in Geelong, only purchased the 1 vessel, and but we developed it so it could be expanded. And within 6 months, they've already added a 2nd vessel in there. So effectively, that doubles the size, but you're using the same electrical controls and some of the same infrastructure, so it just reduces the cost to expand. And you take it to the next level. That's the expanded version. And then we go to a system here, which has got 4 units, which is one that we've got sitting in Saudi Arabia. And, we can just keep adding vessels as the volume and the requirements grow. Okay, the 3518, which is our big girls, we've got 3 units sitting in Buenos Aires at the moment, installed in 2015. So each one of those vessels will do 10 tonnes a day, and they're just about to install a 4th unit. We have 2 vessels in Rochester in the UK, and that's dealing with sewage grits and screenings from all the roadworks, and it's been installed since 2010. And then they take that and they basically take that end product and use it back into agriculture. And then saying we've got another sewage plant in Grabo in South Africa, just dealing with the waste, from a local town. Again, possible layouts, we can look, this is a 3518 plant. You look at the area there, you're talking about a 2,000 square metre footprint, and that system there would hold up like that, will do 20 tonnes a day. So, if you've got 20 tonnes a day coming in, say, into an open windrow application, the amount of space that you're going to need, to store that, to compost it over a 6-month period is huge compared to something that we can do in a very, very short space of time. And again, it's just typical how we can expand it. Some other layout, just, how we look at different different things that we can add to it to develop the whole site to make it effective for you. These are just some examples. Okay, so I'm just taking an example of costs here. So typical installation of equipment, what's required. So your requirements, if you were looking at a system that was doing, 8,000 tonnes per annum, you'd be looking at the 2 vessels, your shredder for the green waste and an on-site loader. Your land requirements would be 2,000 square metres and 3-phase power. That's all we need. And then you'll need a storage facility, somewhere to store and receive the waste, a trommel, and some composting storage at the end of the process. Typical operating costs. I'm sorry, I'm just trying to, I can't quite see that slide, but if you can see there, I've just run through. So maintenance, we typically would allow one of our systems around $4 per tonne processed. So if your system is doing 10 tonnes a day, you'd put $40 a day to one side to cover future maintenance over the life of the equipment. Sorry, I'm trying. I've cut off half my presentation. Oh, here we go. That's better. So if we look at a system, estimated capital cost for a HotRot system, excluding mobile plant, So a typical 8,000 tonnes per annum, which is the 235/18 vessels, a capital cost is going to be about 3.8 million, which everybody thinks, whoa, but we depreciate that over 10 years and you've got 75,000 tonnes of materials processing. So we're talking about, $51 per tonne processed over that 10-year period. We add the power consumption to that at 17 cents, which is about $4.50 per tonne processed. And then maintenance costs of around, okay, $5 per tonne processed. And then add your labour to it. So all of those factors added up, it's about $72 per tonne processed. Now, I'm not sure about your region, but I know here in Christchurch now, where I think to send waste like this to landfill, we're talking about $180 a tonne. So all of a sudden, and what we're seeing in recent times is that the HotRot system has become a very economic and viable solution, because you've ended up with a product at the end of it, which then you've got value. The end product has got a lot of value for agricultural farms, general composting, and it's becoming a highly sought after commodity. And we can prove that we can process it based on how experience and history now, for, like $72, per tonne, approximately. So that just gives you an example of what's possible. So how does it work? A project of that size, and this is a large project, but you'd be scoping and design would take it 2 months. We allow 3 months for doing contracts. Manufacturing is 6 months, and then commissioning and training would take us about a month. That's for a big system. Some of our smaller systems, like our 1811, we have manufacturing time of about 12 to 14 weeks, and typically we could probably have a system delivered, manufactured within 6 months if you're only talking just a couple of thousand tonnes a day that you want to process. And finally, this is just our contact details, and thank you. I hope I haven't confused or bored anybody, and happy to answer any questions.